So far we have looked at the urinary system, the different parts, how the kidney is able to filter waste out of our blood for us, and how that waste becomes urine. So in this lesson, we are going to be looking at what we call urinalysis. It is a clinical lab that is done to look at what's in a urine sample from a patient, and it's going to give information to the doctor about what could potentially be wrong with that particular patient. So urinalysis, what is it? It is basically the analysis of urine, kind of like the name tells us. It's one of the oldest lab procedures done in medicine, and it's a good test for doctors to get an overall idea of the health of a patient. It's going to give information about the state of the kidney as well as the urinary tract, so you can see if there's an infection or kidney stones or any problems like that. This test is also able to let a doctor see possible issues or diseases that might go unnoticed otherwise because there aren't like telltale signs or symptoms of those diseases. So examples of that could include diabetes mellitus, which that is the typical diabetes that we hear of people having as far as type 1 and type 2 diabetes. Kidney failure also shows up. You can tell if somebody has a UTI or a urinary tract infection. So it does give a lot of information to a doctor. And it's a relatively easy test for the patient to complete because you need to just provide a urine sample at a doctor's office, and then they would send that out to be analyzed. So just really quick to review the function of your kidneys. Kidneys are going to filter your blood and get waste out of your blood. They're also going to allow things to stay in your blood that should remain in your blood. When waste is filtered from your kidneys, it's going to become urine. Urine is composed of approximately 96% water and 4% dissolved substances. And those dissolved substances are going to come from your food or be the waste products of metabolism, so you using your food to make energy. The actual composition of urine will vary, depends on a person's diet, their metabolism, how efficient they are at turning their energy or turning their food into energy, the general health of the body, as well as the health of the kidney or kidneys. And a urinalysis test is performed to assess the urine's composition as well as kidney function. So just to review real quick again, we see the parts of the urinary system here. You've got 2 kidneys, 2 ureters, 1 bladder, as well as, it's not in that list, but you also have the urethra so that urine can leave your body. Also, let's recall the role of blood, which is to bring nutrients and oxygen to cells of the body and to take waste materials away from your cells. The kidney has the biggest role in controlling the composition of your blood as far as chemicals go in order to maintain your cells functioning properly in your body. So it's really important that your kidneys are able to get out from your blood what they need to filter out. In the kidney, blood is going to go through filtration and dialysis, which separates the waste compounds that will be removed and become part of your urine, as well as returning substances to your blood that should remain within your blood. So you would have blood with waste going through the renal artery into the kidney. That blood gets passed through the glomerulus and filtration happens with the nephron. And then clean blood leaves the kidney through the renal vein. So if we look more specifically, the kidney has functions of removing waste products from the blood, retaining nutrients such as proteins and glucose that your body should hold on to, maintaining the acid-base balance of your blood, so that should be between a 7.35 and 7.45. So your kidneys help the blood to stay within that range as far as pH goes. It's going to regulate the water and electrolyte or salt content of your body. It's also going to be responsible for producing hormones. And then to be specific, that hormone would be erythropoietin produced by your kidneys so that your red bone marrow can be targeted to make more red blood cells. When urine is formed, that happens in the kidney in a structure called the nephron. Each kidney, just to review, we have about 1 million nephrons per kidney. And it's made of a glomerulus, which is the little ball of capillaries that we see right here inside of Bowman's capsule, as well as a set of tubules. Urine is going to be formed through 3 processes that happens in the nephron, in different parts of the nephron. And it's going to be filtration, reabsorption, and secretion. When glomerular filtration happens, that's going to be followed by tubular reabsorption as well as secretion. And that can be affected when the kidney is compromised by disease. So if you have renal disease of some kind, your kidneys will not be filtering your blood properly. Sometimes renal function can be lost for different reasons, and remember that renal refers to your kidneys. So kidney function can be lost because of things like congestive heart failure. There might be injury to the glomerulus or the tubules of the nephron that can be caused by drugs or heavy metal exposure. Also, viral infections can lead to them stopping working properly. Diseases like diabetes, hypertension, which is high blood pressure, and kidney stones can also cause the loss of renal function. So now we get into a urinalysis. Now that we did that little bit of review, renal function tests or kidney function tests like a urinalysis are used to screen or identify the cause and extent of renal dysfunction. So the cause and extent of your kidneys not working. And there's 3 parts to a urinalysis test. There's a macroscopic exam where you would look at the color and the clarity of a urine sample. A chemical exam where you would use, in the case of the lab we're doing, a test strip to detect different substances in the urine sample. And then a microscopic exam of the sediment. So you would centrifuge a urine sample and take any sediment or solid particles in the urine would settle to the bottom. You would take some of that and put it on a slide and look at that under the microscope. So here we go again. Basically what I just went through on the previous slide. The macroscopic exam looks at the color and the clarity. The chemical exam is going to look at pH, specific gravity, protein, blood, nitrate, leukocyte esterase, glucose, ketones, bilirubin, and urobilinogen. It does say pay attention to the times because when we're doing a lab next week, in this case, we will be using test strips, and there are different times that all of these chemical reactions happen in for us to read levels for these different chemicals found in the urine. And then the third part is a microscopic exam. In the case of our lab, you are going to be given a picture of microscopic sediment because we'll be using fake urine samples and there's not going to be actual sediment in it. So for the macroscopic exam, it's going to look at the physical properties, including color and clarity. So for color to be normal, it's going to be yellow. A straw to an amber color, yellow is considered normal. Abnormal color could be due to disease, drugs, or diet. Pale to colorless, so your urine should not be clear. It should have some yellow to it to show like that comes from the waste that's being filtered out of your blood. Amber meaning a very dark yellow. So even though for normal we have straw, which is pale yellow, to amber, you really don't want amber because that is too concentrated. Orange, pink or red, green, and brown or black. So all of those colors would be abnormal. We'll watch this real quick. It's the best show ever.
Dwight Schrute, Assistant Regional Manager. You might remember testing my urine a few years back when I was applying to be a volunteer sheriff's deputy.
We test a lot of urine.
Mine was green.
Oh, right. How are you?
Oh, I'm all better.
So there are different colors of urine that can indicate some problems. Now for continuing on with the macroscopic exam, you would also look at the clarity or transparency of the urine in addition to looking at the color. Normal is clear, so it should not look hazy, cloudy, or turbid. Those would indicate abnormalities. It could be cells in the urine sample, crystals, different things like that. We'll look at some of the sediments that could be in urine. Okay, so from left to right, just looking, you would have straw, and it's clear. You can see through it. Yellow and clear. Yellow and hazy, so you can see that it's yellow, but you can't see through it like you can these two. This is another yellow clear. This is red-orange. That would also be clear. And then brown, this one would be hazy, just to give you some ideas of what different urine samples might look like. For the chemical exam, that's going to look at the presence of both normal and abnormal chemical elements in the urine, and they're going to be detected using a dry reagent strip. Those are plastic strips that have absorbent pads on them to absorb the urine sample, and then chemical reactions happen in that urine sample or on the strip from the urine sample to allow you to figure out specific substances that would be found in the urine. And just a note down here, a reagent is a substance that is going to be part of a chemical reaction when it's added to a solution. So that will react with the little pads, and you'll see in a minute what the strips would look like. Okay, so right here you would see a strip. Okay, it's hard to tell here. You'll see a better picture later on. These little absorbent pads, you would dip that whole strip into a urine sample and take it out. Chemical reactions would happen on each of those little square pads on the strip. And that's going to result in a specific color change that we can see here. And we'll get to a better slide to show you that in a second. So after a certain amount of time, so for example, when you take the test strip out of the urine sample, you would start a timer. And at 30 seconds after you've taken the sample out, or the strip out of the sample, you should look at the glucose and get your reading for glucose, and then time continues on and you check your next substance. What's going to happen is each of the squares will change a different color. Okay, so we're going to be not able to test all of these things in our urine samples, but here we can see the different substances, and you can see the different times. So glucose will be red at 30 seconds, as is bilirubin, but we won't be testing for that in ours. Ketones, specific gravity, if there's any blood, pH, protein, urobilinogen, nitrite, and leukocytes. So all of these different times here are what you would have to read those tests at to check for the results of the urinalysis. All of where we have these red boxes, those red boxes indicate what would be normal. Okay, so we'll be able to refer back to this in the lab that we're going to do for urinalysis. For the chemical exam, the intensity of the color changed is usually proportionate to the amount of substance present. So here you can see what these test strips would look like. You would hold this end and dip all of this into the urine sample. So it should be in a tube or a beaker with enough urine in it that you can get all of those little absorbent pads or those reagent spots on the strip to come in contact with the urine. Okay, so that they can change color and have different reactions so you can read the results. So typical tested substances and their significance, pH, is going to give you a partial assessment of the acid-base balance. Alkaline pH or a high pH is going to indicate either an old urine sample or a UTI. Specific gravity shows the state of the kidney as well as hydration of the patient. Protein will detect specifically albumin, which is a plasma protein in our blood, and that is going to be an important indicator of a detection of renal disease, so you should not be seeing protein usually in a normal urine sample. Glucose will primarily detect glucose, which is a form of sugar, and it's also an important indicator in diabetes mellitus or type 1 or type 2 diabetes. Blood, you might see red blood cells, hemoglobin or myoglobin. It is a sensitive early indicator of renal disease. So if you find blood in a urine sample, that could show that a person is going to be developing kidney disease or is in the early stages of that. Just to point out a term here, hematuria is the presence of blood in the urine. We'll need that term later on. Ketones are a normal product of fat metabolism. It's going to be increased in amounts if a person is diabetic or if they are, extreme dieting or following kind of like a ketogenic way of eating. Bilirubin detects bilirubin, which is a product of red blood cell breakdown, and it is, let me fix that. It is going to be an indicator of our liver function. Urobilinogen is another product or byproduct of red blood cell breakdown. Increased amounts of seen if somebody has fever, they're dehydrated, have a condition called hemolytic anemia, or if they have liver disease. Nitrate will be seen if there's a certain bacteria present that is responsible for converting normal urine to nitrate and nitrate. It's also an indicator of a UTI because that's caused by bacteria. And then leukocyte esterase is going to detect the esterase enzyme present in certain white blood cells, and that's another indicator of a UTI or urinary tract infection. So chemical results that we can see if we look here, we have normal on the bottom. This would be an elevated pH or an alkaline pH to let us see kind of where that color change would be. A positive test for glucose normal would be here. We would have positive glucose reading there. Positive for blood and for ketones. So these two, again, normal would be down here for comparison. Positive blood and leukocyte esterase. So this would be blood. This is leukocyte esterase. Down here is what normal would look like. Next, we have the microscopic exam. That is, again, going to be used to detect renal or urinary tract disease. And that is going to, again, like I mentioned earlier, allow you to look at the solid material in the urine. Urine sample will be centrifuged, the liquid portion will be poured off, and you are left with the concentrated cellular sediment at the bottom. You would make a microscope slide of that, and then examine it under the microscope. Some normal and abnormal cellular elements that we could see in sediment would include red and white blood cells, which we shouldn't find, mucus, epithelial cells, which are skin cells, different crystals, and bacteria. So here we found red blood cells. A few is normal. Okay, so like finding just a few like this, but you should not be seeing lots like we have here. That is an indicator of renal disease, kidney stones possibly, and can be a result of bleeding at a certain point in the urinary system or the urinary tract. For white blood cells, again, a few are normal, but a high number would indicate either inflammation or infection somewhere in the urinary or genital tract. Mucus are going to be these long thread-like things that we see in here. That is a common finding, so this wouldn't be concerning at all because mucus is secreted by glands along our urinary tract. Epithelial cells, so each one of these is an epithelial cell. Those cells are pretty large and they're flat. Those are normal cells that line the UTI and the genital tract or kidney tubules, so those are normal findings. There are crystals as well that can be found. Some are normal. We can see up here, some of these would be normal. Down here, those would be abnormal to find in urine. So we have calcium oxalate. You can see what they look like right here. And then crystals of triple phosphate we have right there. So you can kind of see that one's pretty common, not clinically significant at all. Hyaline cast we have here. This is just an epithelial cell. They are colorless. They're thicker or like wider than the mucus would be, so that's how you could tell them apart. It could be a sign after increased strenuous exercise, and it can be showing when protein is solidifying in the nephron. And then that is the last crystal we'll look at. We'll come back to some of these when we do our urinalysis lab.